Here is part 2 of the video. Now I'm going to be going over variability, which is different from just finding the measure of central tendency because that only gives you one specific typical attribute of the variable. It doesn't tell you the wide range of variables. So, for example, if I had two classes and I wanted to know what the test scores looked like in those classes. If I just looked at the mean, let's say both of the averages were 82%. So right there, that would look like both of the classes are doing the same. But if I looked at the variability of the scores, meaning the highest and the lowest scores, how wide is that range? It might look a little different. So let's say this first class ranged from, let's see, here's the middle, 82%, ranged from a 93% to a 72%, okay? So they scored like a low C to an A in that class. But the median or the average was still an 82. But in class number 2, let's say the range was a lot different. Let's say the lowest score was a 36% and the highest was 100%. That is a lot different than the low score being 72%. So finding the variability in your variable can paint a better picture for people that are interested in your variables and for yourself. So let's start off talking about range, which the range are the lowest and the highest attribute in your data set. So let me be a little bit more specific here. When they're talking about attributes now, they're talking about individual answers or scores, especially for like interval and ratio level variables. So let's say I'm looking at age in a classroom. Let's say the lowest age is 16 and the highest age is 36. This would be the range, and there's all these people in the middle here too. But that's the range. And to find out what the actual the value or the number of attributes within this range, we would just do 36 minus 16, which is 20, and then you would add 1. So the range or the number of attributes for this variable are 21. Now you might be asking, why are we adding a 1 here? Why aren't we just minusing these two numbers? Well, I will show you. So let's look at this. We'll do it very clear. I'll list out all the attributes. Let's say all the attributes are the numbers 1 through 5. Let's say it's Likert scale, and those are the only options that you can choose. So if I did try to find the range, I just did 5 minus 1, it would be 4. But if you go back and actually count the attributes, it's 1, 2, 3, 4, 5. There are actually 5 attributes. If you just minus the top from the bottom, you're going to lose out on this attribute, and you don't want to do that, so you have to add it back in. So that's why we add 1 here. Okay. So the next thing we're going to talk about is what if there is an outlier like there was for the mean that might skew this range. Okay. So let's say that I do have, here, I go 18, 19, 20, 21, 21, 21, 21, 24, and let's say I do 47. Let's say these are ages in a classroom. So pretty consistent, 18 to 24, like it's pretty similar, and then you jump to 47. This would then make my range of attributes, let's see, 47 minus 18, which would be 29, plus 1, which is 30. So you would have 30 attributes here, or possible 30 attributes, but if you only have this many here, you only have 10 attributes total, but the range is saying you have the range is saying you have 30. That's because it's skewed. It's not really giving a good idea to other people what your actual range of your classroom is. So here you would do an interquartile range. That means you're taking off the top, they're taking off the top 25 and the bottom 25%. So let's say here we just do that, take that off. Okay, so now let's say, now we look and see here. So then we would just have 24 minus 19, which would be 5. Then you add 1, which would be 6. So now we have 6 attributes. 6 is a lot different than 30, and it gives a better idea of how similar the ages are in that classroom versus before. 30 would make me think that there's a very wide range and there's a lot of different types of ages in there. So that's one reason that you would use this if you have an outlier or a number that is very different than the rest of your numbers. Okay. Now let's move on to variance. Variance is referring to, well, how different are the rest of your attributes or your numbers than that typical number, the mean. So if you want to turn to page 57, it gives a really good example here of how you would actually mathematically find the variance, which I'm not going to go into because it's on page 57. It's very clear. Variance is important because it's going to play into when we do statistical tests down the road. You want to know what your variable looks like. How different are your numbers? And if you have outliers, do you not have outliers? Are they all the numbers, all the ages really close together, 18, 18, 19, 19, 20, 20, 21, like very close together? Or are they 6, 9, 21, 57, 89? Are they very spread apart? That would make a very big difference. Okay. So let's talk a little bit about standard deviation. So here, standard deviation, you have to have an interval or ratio level of a variable to be able to even do this, because it's very mathematical. It wouldn't make sense to use for ordinal or nominal variables.